This is Mission Commander Tom Crop with Team 11-4 Jackhammer. We have just managed to get enough power to send a transmission using our wind turbine. Let me introduce you to my team.
Salutations. This is Communications Officer Thomas Cotton.
Hi, this is Ryan McEnany, Chief Engineer Number 1.
And this is Ryan Pelzier, Chief Engineer Number 2. Godspeed.
So this is our whole team, Jackhammer. Things look a little shaky. It's because, well, our final design didn't turn out exactly as planned. So let's just run through what it looks like though.
Our initial approach was to optimize our performance. So this included gears that we 3D printed from NextGen. Additionally, we have an S-shaped kind of cosine sine curve for the wings. We were looking to maximize drag as our main generator of rotation. Below, we settled on a box as it was most structurally secure, and it also kept our Arduino on the inside, and that powered the computer, which didn't power the computer, but that's how we read our power outputs.
A lot of engineering went into the process of designing our jackhammer turbine. Originally, we started with 3 blades instead of the 2. We ended up cutting that down to just the 2 because it seemed to be more costly and a little heavier. The blades were bigger in the thought that it would capture more wind, but we ended up cutting it down a bit. We made the blade out of aluminum foil, but originally we were planning on construction paper, but construction paper just didn't really hold up well against the fan. Next, we used a 1/2 inch dowel as opposed to the original 1/8 of an inch dowel because the 1/8 of an inch was not sturdy enough to hold the entire turbine up. As for the box, originally we started with a 2-layer corrugated cardboard and duct tape kind of mixture, but that just didn't hold up the turbine well and wasn't a good base, so we ended up using a repurposed shoebox. We also had suction cups that we didn't end up utilizing and just used hot glue.
As far as material is used, we ended up spending 146.5 ship parts, which was pretty cost effective for the size and intricacy of our design. Most of our ship parts went into cardboard, so our base ended up being 40 ship parts, and the blades ended up using a lot of cardboard. As far as the rest of the wings, we used tin foil and tongue depressors, which ended up also being a huge cost. We spent 20 ship parts on tools. We ended up getting a lot of use out of this as we used hot glue for the base, for the whole construction of our turbine. The extra costs went into gears and the fidget spinner. At first, we bought a lot more than we needed. We spent money on things like a zinc sheet, construction paper, things that we didn't really need. So we ended up spending a lot at first and having to sell some back during the process. But overall, we finished with a decent amount of ship parts for the design that we had.
Our design results ended up yielding 0.6 millivolts, 0.05 milliamps, and a whopping 1.09 to the -7 watts of power. So that was a little bit underwhelming, but we could have done better, and here's why.
So when we're talking about iterations and why we went with 2 wings instead of 3, the weight of our design was more than we expected. The fan struggled to push our wind turbine around to produce enough velocity to get those gears spinning. Also, as we noticed, we had only 1 iteration of our gears, and these gears didn't fit together perfectly. If we had more time, we would have spent more time having less friction between these gears and also make sure they fit properly. Another iteration we could have implemented was a bigger gear ratio. Because this spins so slowly, but it had a lot of surface area, it would in fact spin, but not fast. So what we could have done is made this gear bigger and our gear on the motor smaller, and had smaller teeth in order to have the gears fit together and spin correctly. Another reason why we didn't perform as well as we wanted to, we had a spinner, rotational axis. This was thought to have not a lot of friction when it was spinning around. But what we found is that the support on our box up here was causing it to have a lot of friction. While it supported it, it also slowed it down a significant amount. I think also for our design, we could have had just overall better construction of the wings, and possibly just sourcing outside help to help us optimize our performance of our turbine.
Commander Berkey did warn us about how difficult this project would actually be.
Rest in peace. His blessed soul.
But here's some footage of how it actually looks.
We learned a lot throughout this project, but we're running low on power.
We're so cold.
Help.
We'd love to take our new skills onto the next project, but for now, we're gonna have to bear with this cold.
Team 11-4 Jackhammer signing off.